Everyone, thanks for joining me on Last Minute Maths. In this video, we're going to be going through the EDEXCEL GCSE Maths Paper 2 Higher Tier from June 2019. And I'm going to work through this one in real time. And by necessity, I'm going to have to rush through it a little because it is actually quite a long paper. So I'll do my best on that to try and keep it short. But as always, I will use each question as a short revision of a topic where necessary. If you have any questions on any of the methods or the questions themselves, please do leave a comment. And if you find it useful, then please do subscribe, like, and share, etc. All right. With that, let's get straight into it. Question number 1. We have an inequality. All right. As you can see, 14n is greater than 11n plus 6. All right. So exactly like a linear equation rather than inequality, we do exactly the same thing. We want to get all the n's onto one side. So you've got 14n minus 11n is greater than 6. Sign stays as it is. So 3n greater than 6. And as always, you just divide the 3 to the other side. So n is greater than 6 over 3. Therefore, n is greater than 2. That's your answer. Okay. Part B. Number line, and you've got a double inequality here. All right, so watch out for that. The way to do these is to treat each half as an equation in itself. So the first one, minus 2 is less than x plus 3. All right. Do that one first. Exactly as before, take the 3 to the other side and it becomes minus 5. So x is greater than minus 5. All right, that's the first condition. The second one is x plus 3 is less than or equal to 4. All right, same again, take the 3 to the other side as a minus and you get x is less than or equal to 1. Okay. Now, how do we show it on the number line? The way to do this is when a number is like, actually, I'll make it over here. When it's less than or greater than only, all right, that sign there, you want that to be a hollow, okay, a hollow circle, because x cannot be 5 or minus 5. It has to be greater than. Okay, and on the other side, where you have less than or equal to, in this case, we use a solid, right? Because x can equal 1, and then anything less than that. All right, so that one's a solid. So the answer looks like this: hollow circle over the minus 5, and a solid circle over the 1, and then line in between. Okay, and so do remember the types of circle to use on a number line. All right. Okay, question number 2. It says, on the grid below, draw the graph of y equals 2x minus 3, and they give you specific values, minus 2 to 4. All right. Now, the reason they've left you all this space here is they're expecting you to do a graph table. All right, so a table of values for x and y in that range, minus 2 to 4. So what you want to do, just put a table there. You don't need to draw lines or anything like that. Just put x and y and the values of x that we want, minus 2, minus 1, 0, 1, 2, 3, and 4. All right. Now, what are we going to do? For example, the first one, y equals, when x equals minus 2, we have 2 times minus 2 minus 3. Okay, so that's minus 4, minus 4 minus 3 minus 7. So we're going to put in each value of x into the equation for the straight line, the graph, and get the values out. And effectively they come out like this. So when it's minus 1, it's minus 5, then minus 3, then minus 1, and then we got 1, 3, and 5. Okay, So once you have that table of values, you can go ahead and just actually plot it on the grid. Now, if you want to save time, you want to be quick about this, you don't need to plot all the points, okay? Take the first one and the last one in the range, okay? So when x equals -2, y equals -7, so that's over here. And then you've got when x equals 4, y equals 5, all right? So x equals 4, y equals 5, over there, all right? And we know from the equation itself, if you remember, that the y-intercept is -3. So when x equals 0, y equals -3. So you literally could just plot 2 points minimum, right? Possibly 3, and join those up, all right? So let's go straight for that. I think that works. There we are, all right? That is literally all you need to do. There are alternative methods, and if anybody's interested in how to do a straight line sketch without plotting points, then please leave a comment. Okay, number 3. Hannah's planning a day trip for 195 students, and she takes a sample of 30, okay, and asks each of them where to go, and they give their answers accordingly. So of the 30, you've got 10 want to go to a theme park, and then there's 5 in theatre, 8 want to go sports centre, 7 seaside, etc. Okay, what they want you to do is work out how many of the total 195 students, right, would want to go to the theme park based on this sample. What we use here is that the fraction that the theme park represents in the sample will be the same as the whole population. Okay, so in the sample, theme park equals 10 over 30. So 1/3 of students want to go to the theme park, right? So we apply the same fraction to the total number 195. Okay, so 1/3 times 195. And of course, you could use your calculator if you wanted. And all right, 3 into that. Let's see what we've got. 60 and 5 there. There we go. All right. So the answer is 65. Now it says state any assumption and explain. All right. So the assumption is that the sample represents all the students otherwise the answer will be different. Right, there we go. It doesn't need anything more than that. It's only 1 mark. Number 4, container is in the shape of a cuboid. We have the measurements, right? Length, width, height, etc. And really important to note, the container is apparently 2/3 full of water, and a cup holds 275 milliliters of water. And it says, what is the greatest number of cups that can be completely filled? All right, so we're looking for whole cups. All right. So first of all, we want the volume of the container, and we all know that's just length times width times height. Okay, so that's going to be 30 times 6 times 19, and it doesn't matter what order you write it in as long as you get the 3 different dimensions. And the answer for that, right, will come to, let's calculate it, 3420. Okay, cubic centimeters. Now, here's where the important bit comes in. 2/3. So it's 2/3 full. Therefore, 2/3 times 3420. I think that comes to 2280, I think. 3420 times 2 to 3, and that's 2280. All right. Now we want to see how many cups we can fill with that. So the number of cups equals 2280 over 275, and that is going to equal 8.29. So the whole number of cups is 8. Okay. Now, one really important thing to note, in case you're not sure about measures, 1 milliliter equals 1 cubic centimeter. All right. So they're actually the same measurement, really, the same quantity. So please bear that in mind. And so answer 8. All right. Okay, number 5. This straightforward trigonometry SOHCAHTOA question. All right. And they want us to find the length AB. So it's this side here. All right. We know the hypotenuse, the diagonal, is the hypotenuse, and we're given the angle 38. All right. So we want to find AB, which in this instance is the opposite to the angle at vertex C. So ACB is 38 degrees, fine. AB represents the opposite to that angle, and in case, just want to expand the thought, BC is the adjacent. All right, so bear that in mind, and we're going to use SOHCAHTOA. All right, so we want something that relates the opposite to a known quantity, which is the hypotenuse. All right, and so looking at our SOHCAHTOA, it's the first bit. Sine of an angle, so in this case 38, equals the opposite over the hypotenuse. Okay, so that takes into account what we have in the question, and that effectively is AB divided by 16. All right, so therefore 16 times sine 38 equals AB, and that comes out to be 9.85 after rounding. Okay, so 9.85. Right. Number 6. Sally used a calculator to work out the value of a number y. The answer on a calculator display began this, and that means there were other numbers after it. Okay, we don't know how many or what, but it began with 8.3. This is called truncation. It's not rounding, okay? You're not looking for a rounding range, upper bound, lower bound, nothing like that. It's actually truncation. So basically that number, the next number could be 8.3, 0, etc. Okay, and it could go all the way up to 8.3 and then a whole load of 9s. Okay, anything short of 8.4. So, you could have a whole load of zeros if you want, like that, or you could have a whole load of 9s. Okay, so effectively the range, the error interval for this is 8.3. So y can be equal to 8.3 or more, right? But it has to be less than 8.3999. So it's less than, right, 8.4. Okay, so watch out for this. This is not an upper lower bound question. It's a truncation question. Make note of that. Right, number 7. We have £360 shared between Abby, Ben, Chloe, and Dinesh. So A, B, C, D. All right. Right. And then we have ratio of Abby to Ben. So A to B is 2 to 7. And then it tells us that Chloe and Dinesh each get 1.5 times the amount Abby gets. All right. So if Abby gets 2 parts, if you like, with the ratio is 2, then 1.5 times 2, 3. So each of them get 3 parts. Okay, like that. And so the total comes out to be 9 and 6, 15. 15 parts. So we want to find out how much each part is worth. So each part equals 360 divided by 15, and that effectively 24. And then we want to know how much money Ben gets. All right. So Ben gets 7 parts. 7 times 24, and that I think comes out to £168. Okay, so the total there is 168. All right. Number 8. Okay, standard form. In standard form questions, always start with whatever number you're given. Take the digits of the actual numerical value, so in this case the 562, and start with a value that's 5.62. All right, because the rule in standard form, a times 10 to the power b, let's say, is that a must be between 1 and 10. Okay, so a has to be less than 10 and greater than or equal to 1. So it's got to be in that range. All right. So the best way to do it is always to put a decimal place between the first 2 non-zero numbers. Okay, non-zero numbers. All right. So you got 5.62. What would you have to do to turn it into 0.00562? Right. So effectively, you're moving the decimal once, twice, 3 times. All right. So 1, 2, 3. And that's where you would have that. Okay. And so effectively that means in order to get back to a smaller number, 0.00562, you take 5.62 times 10 to the minus 3. 1, 2, 3. All right. So 5.62 times 10 to the minus 3. Because with that number, you need to move the decimal place to the left there, making the number smaller. So it's 10 to the minus 3. On this side, you've got it in standard form already, 1.452. And then you want to times it by 10 to the 3. So because you're enlarging it, you're making it greater, bigger, you are going to move the decimal place to the right. Okay. And how many times? 3. Right, 10 to the power 3. So it's 1, 2, 3. Okay, so that simply becomes 1,452. All right. Now, fairly simple, that one. Okay. Right, number 9. Now, the wording of this question is something you have to watch out for, and the order in which you get things. You've basically got 2 circles, all right? A, and one that's slightly smaller, B. All right. And they're saying that the circumference of B is 90% of the circumference of A. All right. So they're taking ratios of the length of the circumference. All right. Now, very simple, without going into all that detail. And this whole question rests on this particular principle. If I have a shape like that, and then I, for example, double the lengths. So in other words, the plane dimension scale factor is 2, for example. So it'll be twice as wide and twice as long. Okay, like that. So now look what happens. The area that I had originally, A, I've now got 4. So if length doubles is times 2, then area is times 4. Okay, and the simple rule on this is that if you have a length has a scale factor, all right, then the area is given by whatever the length scale factor is squared. And if you were to be asked about volume, then it would be the scale factor of the lengths cubed. All right. So just a quick bit of revision on that. So what that means is when they want you to find the ratio of the area of the circle A to the area of the circle B, okay, we know that the radius of A, so radius A to radius B is, and I'm going to use whole numbers, it's 90%, remember, is the same as 0.9, right? So 0.9. And if you then were to square that, because that's a scale factor, 1 to 0.9, right? So the area of A to the area of B is, again, 1, but then you have the scale factor squared, which is 0.9 squared. So call it 1 squared, 0.9 squared. That's the same as 1 to 0.81, okay? So if you want to then express that in integer terms, like find whole numbers, multiply both sides by 100, okay? So times 100, just for whole numbers, and that way you get 100 to 81 for a complete ratio. And I think you can leave it as 0.81 if you liked, or 81% or something like that. But please do get it in the right order. You want the A1 first and the B1 second. That's what the question is asking for. All right. Okay. The second part of the question is based on 2 squares, and the squares have length, side length E and F respectively. All right. And the area of square E is 45% greater. So again, the area scale factor, what we've just learned above there. So area of E to the area of F is 44%. That's something I just have to explain here. 44% greater means it's 144%, which means it's 1.44 in decimals. All right. So if we write that as decimals, 1.44 to 1. All right. So if that's the area scale factor, then the length scale factor, if you like, yeah, length of E to the length F is going to be the square root. I just want to switch here. Look at what we have here. Area is given by the scale factor squared. And if you want to go to the scale factor, you square root it. All right. So bear that one in mind. So what that's going to be is that it's square root of 1.44 to square root of 1 is just 1. So that actually comes out to be 1.2 to 1. All right. And it can be left like that. But again, it's nicer to turn it into whole numbers. So if you've got a 0.2, times it by 5. Okay. and that gives you a ratio of 6 to 5 times both sides by 5. 6 to 5 is sort of like a rounded whole number answer. So do that there. Okay. Right. Number 10. All right. It's a probability question with a tree, and the train, it says, will be late on any day. Right. The probability of that happening is 0.15, and that's already shown here on the first part of the tree. And remember the rule, okay? The probability of the outcomes add up to 1, okay? Prob of outcomes add up to 1, okay? That is a really important fact that you must remember. So it says complete the probability tree diagram. So on Thursday, if it's going to be late, that's 0.15, as I've already told you. So the probability of it being not late, right, must be 1 minus 0.15. So that's 0.85, okay? Then the next part of the question, the Friday bit, remember it says that on any day, the probability of the train being late is 0.15, which means it is the same probability every day, right? So same every day. All right, so we just quickly fill that in. It doesn't change. And there we have it. Okay, so that's the probability tree filled in. All right, now it says work out the probability that a train will be late on at least one of these 2 days. All right, now, you know, you've got a whole combination of things. So you've got Thursday and you've got Friday. And what combinations can we have? That it's at least one of these days. So you say late, right, not late, and then late, not late, and finally not late, all right? So the combination of at least one of these 2 days, right? So at least, so that covers 3 combinations there, okay? And that's the one that we want the probability for. Now, because there is only one combination that we don't want, it's actually easier to find out the probability P late at least once is the same as if you take 1 minus the probability of the one that we don't want, yeah, that one. So this one we don't want. So we can actually get rid of that, and whatever's left must be the probability of all the other 3 combinations. So the probability of it being late at least once is 1 minus not late and not late, right? And I'll explain how we get that. It's basically 0.85 times 0.85, right? So when you have not late and not late, the and means you multiply the probability. So that's 0.85 times 0.85, all right? And so the answer for that one, if you put that into your calculator, it's 1 minus, I think it's 0.7225 is what it's saying. And so that comes to 0.2775, all right? You could use exactly this method and work out the probabilities for the 3 different combinations, and then you'd have to add them, right? Remember, if it's or, it's adding, right? But that, I think, is the shortest method of doing that question. All right, let's move on quickly. Number 11, group frequency table. Okay. and they've given you the frequency for each of the categories. All right. From that, and by the way, it's 80 office workers. They're saying complete the cumulative frequency table. All right. What the cumulative means, that for any given category, like that one there, it means how many people, all right, took up to, in this particular case, up to 40 minutes to get to work. All right. So it includes the people who travel there in less than 20. Okay. So if I demonstrate what's going on, 0 to 20, we already know it's 5. Okay. But the people from 0 to 40, you are taking the sum of the 0 to 20 and the 20 to 40. Okay. So effectively, we're adding 30 to that, and you get 35. Okay. In the same vein, you just keep adding on each new category. So that's 55. Okay. And then you've got the next one is adding on 15. So that's 70. And you're adding on 8 after that, 78. And finally add 2. So you're up to the total of 80. All right. So the next thing they want you to do from those values is to plot or draw, it says, a cumulative frequency graph. All right. In this case, all right, remember the brackets that we had were 0 to 20, 40, so 20 to 40, 40 to 60, etc. When you plot a value, a cumulative value, you must plot it for the end of the bracket. So if it goes from 0 to 20 for the first one, you must plot the value at 20, all right, because it includes everything up to that value. So our first value was 5, okay, and they've actually made this particular bit a little bit tricky because it doesn't match up with the little squares. So use a sharp pencil, and that's 5, 20. At 40, we had a cumulative value of 35. So it's a big jump all the way up here. Okay. And then at 60, I think we had 55. Right. And at 80, that's 70. And at 100, we had 78, which is fine there. And at 120, it was a total of 80 there. All right. So just to remind you, in case you're wondering, there, those are the values that we're using. Yeah. So scroll back and forth if you need to, just double check those. Now, to draw a cumulative frequency graph, it's got to be a smooth line through all the points. All right. And that is not easy. Okay. Especially on a screen with a stylus. I'll do my best, but in your actual papers, if you get something like this, use a sharp pencil and just try and draw a smooth line piece by piece if you need. Do not do straight lines connecting the points. All right, let's give it a go. No, that doesn't work. What a bad start on that one. Okay, let's try. All right, I'm not going to waste time correcting it. Okay, that's the best I can do for now. But you get the picture. I think you can interpret what to do here. The next part of the question, it says, use your graph to find an estimate for the percentage. Right, watch out, they want a percentage, not a number. Percentage of these office workers who take more than 90 minutes to get to work. All right, so we want to find the number of people that are up to 90 and find out how many are left above that. So 90 is there. Okay, so we're going to take a line to our graph. Okay, I can cheat because my one makes the line straight for me. And let's take this here. Okay, so reading off that value there, okay, you've got 74. Okay, and remember that the total number was 80. So number okay, that take longer than 90. Minutes to travel to work equals 80 minus 74. That's 6. And therefore the percentage equals 6 over 80 times 100. And so let's see, 600 divided by 80, 7.5. Okay. And do remember, make sure you show the lines. Yeah. All this working must show. It's part of the number of marks allotted for the question. And if your lines are a little bit off, they will allow some kind of latitude, right? So if you're a little bit out either way, they will still allow the full marks as long as you've shown your method and you've shown your workings. All right, so that is really important. Okay, number 12. You've got a sector, all right? Now, the properties of a sector, I'm going to revise that very quickly, just to highlight how to do this question in general. If I take a slice of a pie and I have an angle x in the middle, all right, the length of the arc, okay, of the sector, all right, is whatever the angle I have in the middle as a fraction of 360, because that is a fraction of the full circle. All right, so length, if you like, arc, will be x over 360 times the circumference, right? Which you can call pi d or 2 pi r, whichever you prefer, all right? And the area will be, again, the same fraction of the circle that the angle is of 360 times pi r squared. Okay, so bear that in mind. In order to work out the perimeter, right, we need the length of arc. We need the arc, all right? So that is that length there, okay? What we're given, however, is the area of the sector. So what we're going to do is find the area, right, rather use the area to find x, and then use that to find the length of the arc, all right? So we're given that the area equals 40, and that must be the angle x over 360 times pi r squared, so that's 49 pi, all right, 7 squared, remember? And if we work backwards from there, we find that, now how are we going to do this? 40 times 360 divided by 49 pi. So just rearranging that to get x on its own, all right? And I'm going to do that very quickly. Times 360 divided by 49 pi, right? 93.544, etc. Numbers in your calculator, all right? So now we know the angle at the center. So what we need is that the arc length, using the formula here, is going to be that angle 93.544, etc., divided by 360 times the 2 pi r, if you like, just keep it nice and simple. So that's 14 pi, all right? And again, calculating that out, you get a total of 11.4 4, 3. All right, and I'll write it out. It's 4, 2, 8, 5, 7, etc. So 11.43 in this case is more than enough. And remember, the question says 3 significant figures. Now, the total perimeter equals the 2 straight edges. So 7 plus 7, right? 7 plus 7 plus 11.43. So you've got 25.43. And the answer to 3SF is just 25.4. All right? And so get rid of that. You only want 3 significant figures. All right? So that's that question done. Great. Number 13. Okay. We're going to break this down into like one step at a time. We're going to ignore the 6 for a minute, okay, and tackle what's inside the square brackets, okay. What you have here is x plus 5 divided by an algebraic fraction, okay. It doesn't matter whether it's algebraic or any other form. The fact that you're dividing by something that looks like a fraction means you can rearrange it and apply the usual rule. So it's x plus 5 times, so change the sign to a times and flip the fraction upside down. So we have x minus 1 over x squared plus 3x minus 10. All right. Okay, so what are we going to do with this? We see a quadratic in the denominator, all right, here. So the first thing we're going to do is factorize quadratics. And if you're not sure how to do that or need to revise that, do take a look at my other video on factorizing quadratics. All right, that's in my channel list somewhere. So do take a look at that if you need to. All right. Okay. So what we're going to do is take the x squared plus 3x minus 10 and factorize that into 2 terms there. All right. So you've got numbers. I need 2 numbers that add up to plus 3 and multiply to minus 10. Okay. So the obvious ones are 5 and minus 2. Okay. So we have plus 5 minus 2. Okay. So let's replace our original thing and start putting everything together. All right. So we have x plus 5 times x minus 1 over x plus 5 times x minus 2. Okay. And you can see straight away that the x plus 5s cancel. All right. So we're left with just this bit here. Okay, so now we can bring back the 6. So effectively we have 6 plus x minus 1 over x minus 2. Okay, in order to combine that, we need to get the 6 in terms of something that is over x minus 2. So the best way to do that is to multiply the 6 as if though it's top and bottom by x minus 2. All right, so that can be written as 6 times x minus 2 divided by x minus 2. All right. This is not a different number. X minus 2 divided by x minus 2 is the same as 1. So we're actually multiplying the 6 by 1, but making it into a different form. All right. So we can add it to the other algebraic fraction. Okay, like that. Now we expand the top. 6x minus 12 plus x minus 1 over x minus 2. And when we tidy all that up, we get 7x minus, I'm not sure if I've made a mistake somewhere. Better check it. Hang on a second. Let me add up these numbers. No, that's fine. There we are. All right. Yeah, I just confused myself for a moment whether I needed to change any of those signs, but we don't because it's a plus in between. So there you go, that's the final answer, all right? And that's what they were asking for in the question itself. Okay, so number 14, a car moves from rest, right? So we have a speed time graph, okay? And they've drawn the data onto the thing, so you don't have to plot anything or work anything out from there. And it says, calculate an estimate of the gradient of the graph at t equals 15. So let's jump straight into that, at that point there, all right? And the way to do an estimate of a gradient, right, at any given point on a curve is to try and estimate a tangent, okay? And I'm doing this, unfortunately, without a ruler, so I'm going to have to do this purely by like visual judgment, and I've got to be careful how I do this. Possibly like that, all right? And if I extend that a little bit further, take it up, and what you can do is extend it until you get sort of like whole numbers or something like that. I'm going to take that particular bit there, like that, okay? So you take a tangent, or you estimate a tangent, and then you need to work out the gradient of that tangent, all right? And gradient, remember, is vertical difference over horizontal, which, you know, in your normal stuff is simply the difference in y and over the difference in x, all right? So the vertical bit here, we're going from 15 up to 25. That's according to my graph, all right? And on the bottom here, the time, the horizontal, I don't know, 11, is that 11? It's not quite even 11. 10.5 to 17.5, all right? So 10.5 there and 17.5. So it's 7, okay? So what we're getting here is 5 over 7, all right? And again, they allow you, you know, some variation in, depending on how you estimate your thing, as long as you show the way you've worked it out and you label it as I've done, then that's plenty to, you know, justify your answer and get it. As long as it's not wildly inaccurate, you're fine, all right? So that comes to, I've got 0.71, okay? And I think they're saying that, I'm going to put that in brackets here, just to let you know that if I look up the scheme, I think it said 0.6 to as high as 1, I believe, all right? Do check it if you want to in some mark scheme, but that's well within a reasonable range, all right? Okay, so that's the estimate of the tangent, and part 2 of part A, describe what your answer to part 1 represents, and remember the slope of a sort of like a velocity time, speed time graph is actually the acceleration, all right? It's the rate of change of the speed. So all you need to write, acceleration, all right? And, better not forget that. So that's, my thing was 0.1 and acceleration there. You don't need anything else. You could, if you wanted, I suppose, write rate of change of speed, okay? If you can't remember acceleration on the day. Then it says work out an estimate for the distance the car travels in the first 20 seconds of its journey. And it says use 4 strips of equal width. So they're actually giving you like a hint and a pointer, okay? Distance on a speed time graph. So speed time graph, right? The area under the curve equals distance. That is the principle we're going to be using. And it says 4 strips of equal width up to 20 seconds. So that basically is using, and I'm going to use red for this one, is like that. Okay. And we've already got the blue one there. And so 20 seconds. Okay, like that. And so what we want is the areas for that. I'm just going to label this area 1, area 2, area 3, and area 4. Okay. The way we want to do this area calculation, if you like, all right, is treat each one as a triangle. Okay. So it's as if though that was a straight triangle like that. I'm going to demonstrate it on the first one. Okay. And that one, area 1, the height here is 4. All right. And the base is already, as we can see, 5. Okay. So A1 is going to equal 4 times 5. And then, because it's a triangle, or we're treating it like a triangle, it's 2. All right. Now, that's the only one that can be treated as a triangle. The others are going to be trapezia. All right. So you need to use the area of a trapezium for this. Now, I'm just going to write down the heights here for each one. So we know that that one's 4. This next one is 12. All right. This one here, we will know is 15 and 3, 18 there, I think. All right. So that one's 18. And the final one at 20 seconds is 20. All right. So if you're working on this, then please write that down for a moment, and I will just put the areas at the bottom. So the area of a trapezium, is given by A plus B, so that's the top and the bottom, divided by 2 times the height. All right. Now, in this case, my trapezia, in this particular question, all look like this, or something like that, right? So I'm going to use A, B, and the width is the height, like that, okay? So using the numbers that I had above here, okay, I know I've got the same height, if you like, in each of them. So it's 5, 5, 5, etc., because it's equal width, all right? So all I need is the heights. And I've got 4, 12, and, oh, my apologies. I should have corrected this. 17, sorry, 18, right? Wrote down 12 by accident, sorry. Okay, so 12, 18, and 20, all right? So area 2, so we know area 1, we already worked out is 4 times 5 over 2 is going to be 10. Area 2, now using our trapezium rule, it's 4 plus 12 over 2 times 5. So we have 16 over 2, 8 times 5, 40. Area 3 is going to be the 12 plus 18 over 2 times 5 again. So what do we got there? 5 times 75. Okay. And I'm doing most of this in my head, but you're obviously going to use a calculator in the real exam. Yeah. So don't. I'm trying to save time reaching for a calculator where I can. And the next one is 18 plus 20 over 2. And again times 5, so 39, 38, 39, 19 times 5, 95, and the sum of all of that, 50, 125, 530, 90, so you come to 220, all right? So 220 meters, all right? And just add up all the different areas to give you the distance total. I've tried to do that as quickly as I can. Let's move on. Let's try and fit all of this in. Number 15, make M the subject of the formula. All right, so the first thing we do is, in order to rearrange this, get rid of the denominator. So we multiply across and expand it like that. Then we want to collect all the m's to one side. So expand the brackets, minus f equals 3m plus 4. Bring the m's to one side and take the minus f to the opposite side. So we have fm minus 3m equals f plus 4. All right, so the f goes across as a plus f, positive f on the other side. Factorize the m out, and you get f minus 3 equals f plus 4, and therefore m equals f plus 4 divided by f minus 3. That's your answer, okay? Okay, done. That wasn't too difficult, that one. Okay, now this one takes a little bit more. So the straight line L has the equation 3y equals 4x plus 7, all right? So we're going to work on that equation in just a moment. The point A has coordinates 3, minus 5, okay? So they want us to find an equation of a straight line that is perpendicular to L and passes through A, all right? So in order to find the perpendicular, we need to find the gradient. So the first step, all right, is rearrange the 3y equals 4x plus 7 into a form that is y equals mx plus c. M is the gradient. Okay, that'll tell us the gradient of the line itself. Okay, all right, so rearranging, all you need to do is divide everything by 3. So you have 4 over 3 times x plus 7 over 3. So my gradient is actually the 4/3. Okay. Second bit, perpendicular gradient. All right, we want to find the perpendicular. The rule is that if you have two gradients, they are perpendicular if m1, i.e. of line 1, and m2, so m1 times m2, equal minus 1, right, when you multiply the two, okay? And so let's write it like this. m2 equals minus 1 over m1, all right? So what does this mean? I'm going to put it in very plain language, all right? If you want to find the perpendicular gradient, okay, then your first gradient, flip the gradient upside down and reverse the sign. Okay, that is basically what you need to achieve. All right, so I'll do just one or two examples. I've covered them before in the other papers, but just to show you, if you have, for example, a half as your gradient, right? Flip that upside down, it becomes a 2, and this was plus, so the 2 is a minus. Reverse the sign. Okay. If you had a whole number, right? So let's say 4. you flip a 4 upside down. A whole number upside down is basically a fraction, 1/4, right? Called the reciprocal. And if anybody needs more detail on that, please leave it in the comments. And so again, the 4 started off as a positive, and when you flip it upside down, change the sign, becomes -1/4, all right? Okay, enough said on that. So the gradient we're starting with is 4/3, okay? So the gradient of the second line, the perpendicular line, is going to be 3/4, and the original one was positive, so this one is going to be negative, all right? So right, now we have the starting point of our perpendicular line equation. Y equals -3/4 of x plus c, all right? So that is the y-intercept, okay? C equals y-intercept. Okay, to find c, and again I'm going to put that in, to find c, substitute in coordinates of any point line passes through, which the question actually gives us very specifically, all right? And it tells us that the point A has coordinates 3, -5, and this perpendicular line passes through A, all right? So watch out for those two. So we're going to use those coordinates 3, -5, all right? So A is 3 -5. So y equals -5 when x equals 3 and plus c, all right? So what are we going to do? We're going to, I think the best thing is multiply everything by 4. So you have -20 equals -9 plus 4c, all right? And that is basically -11 equals 4c, all right? So I'm going to write just below the line, so pardon me for doing that. C equals -11 over 4, all right? So therefore, the equation of the line is y equals -3/4 x minus 11 over 4, all right? Yeah, if you have any questions about that particular method or straight lines, etc., then please, as I said, do leave it in the comments. Number 17, all right? This one is perhaps not as bad as it looks, all right? There's one little trick here we need to understand. And look at this. It's only 1 mark for all that reading and writing, I suppose, right? Okay, small cubes and large cubes. And then the cubes themselves are split up into reds and yellows, all right? Fair enough. That's all you need to know from that first part of the question. The ratio of the number of small cubes to the number of large cubes is 4:7. So the total number of parts there in terms of size is 11, all right? The ratio of the number of red to yellow is 3:5, and that total is 8, all right? So that means whatever the total number of cubes is can be divided by 11. In other words, it can be divided into whole numbers, 11 and 8, all right? Because you must have whole cubes. You can't have, half a cube or fractions of a cube, okay? So therefore, if a number can be divided both by 11 and 8, all right, it means that if we want the least possible, that means the lowest common multiple of 11 and 8, all right? Explain why. So just put lowest common multiple of 11 and 8 equals 88. That's all you need, all right? I don't think you need to explain that any further, all right? And if you've shown, actually I better write this, show totals in your answer. Okay, as long as you have those totals there, then the rest of the answers can be kept quite simple, all right? Okay, all the small cubes are yellow, right? Small cubes are all yellow. And that effectively means that they are 4/11ths of total. So that's 4/11ths of total equals, or rather are yellow already, right? Their small cubes are all yellow, right? And so that gives us, and we're, remember, working the least possible number again. So that's, again, 88, all right? So 4/11ths of 88, right, is 32, okay? But the total number of yellows equals 5/8 of the total, all right? Equals 5/8. I'm looking at the ratios at the top of the question, all right? Just to avoid any confusion. 5/8 times 88 again equals 55, all right? So the difference between the yellow small, so small yellows, and the total number of yellows must be 23, all right? So from there, we can work out that the least possible number of large yellow cubes in the bag must be made up from that difference. So large yellows must be 55 minus 32, 23, all right? So that's how we work out the proportion of those. All right. Got it. Number 18. Now this one, you've got to be very thorough in the way you do things. So we have the information in the question: A, B, C, D lie on a circle, and they've been joined, right? Look at that. There and there, okay? And CDE is a straight line, okay? So we note that bit of data there. Then we have these signs when you've got, that thing there and that thing there. It's telling us that BA and BD are equal, right? And then BC and CD are equal to each other, right? And we've given one angle at the top there, ABD. So what we need to find out is work out the angle ADE, right? So we want that angle there, all right? In order to work that angle there, we need this one here, and we need that one there, all right? To get rid of the other angles. Okay, so the way to do this, start with the 40 degrees that we have, all right? We can see that our triangle ABD is isosceles, all right? So the angles at the base, all right? So angle BAD and BDA are equal, okay? So I'm going to start with that statement there. Angle BAD equals angle BDA, and because angles in a triangle add up to 180, as we know, 180 minus 40 must be the sum of the two angles, all right? So we're going to write it like this: 180 minus 40 divided by 2 equals 70, all right? And the reason for that is that triangle ABD is isosceles. Okay, that's the first point we want to make. All right, then we now know, and I'm going to fill in the bits now. So that's 70 and that's 70. All right. We can then use the fact that this is a cyclic quadrilateral. You can see how this four-sided shape, right, has all its corners on the circle itself. So that is a cyclic quadrilateral, right? How are we going to use that? Let me show you. So the next bit is that opposite sides of a cyclic quadrilateral add up. So apologies, start that again. Opposite angles in a cyclic quadrilateral add up to 180, all right? So this angle here and that angle there must add up to 180, all right? So we can use that fact. So angle BCD, all right? So BCD equals 180 minus 70, that's 110. Okay, and here you can say let me undo that. Don't need to write so much detail. You can just say angles, opposite angles, let's put it that way. Opposite angles in cyclic quadrilateral add up to 180. All right. So that's your reason, your explanation, as it were. And then part 3 of this, or step 3, if you like, is that if we know that that angle is now 110, okay, and we need this angle here, notice that a triangle BCD is also an isosceles triangle, okay? So we're going to use that fact now. And what we're going to say is that angle BDC, right, equals the 180 minus 110 over 2, and that equals 35. So again, we're using the fact that triangle BCD, okay, is isosceles, and you could write that angles in a triangle add up to 180, all right? And finally, you've got these two angles now, all right? So again, this is now 35, okay? Therefore, what we have is effectively two angles on a straight line. We need to find the third, all right? So the way we're going to write that is that angle ADE equals 180 minus 70 minus 35, all right? And that equals 75, okay? And what are we doing? Just writing angles on a straight line, total 180 degrees, all right? And you could write somewhere here, if you wanted, angles in triangle total 180 as well, all right? So your final answer is 75. So angle ADE equals 75 degrees with the full explanations. Right, hopefully that's clear. And just to mention, there is a circle theorems video out there on my channel if you need to revise these. So if any of that's been unclear to you, do take a moment and take a look at that other video as well. That might help. Okay, right, and we're almost there. Okay, so what do we have here is a triangular prism, right? Triangular means the end face, right? And then it gives you a whole lot of data based on this. The base ABCD of the prism is a square, all right? It doesn't look much like it in the diagram, but it is a square because you've got side lengths of 15 and 15. Then you've got this angle of the edge here. The slope compared to the base is 35, all right? So they've given us that information there, okay? And then the upright, EB, has a right angle there, okay? So that is a purely vertical. EB and FC are both pure verticals, okay? Then we have this point. It says M is the point on DA such that D to M is, and ratio of D to M to A is 2/3, right? I won't say it like that. It's 2 to 3, all right? So I'm going to just estimate a point here. Let's make that M, okay? And when we do that, we can actually split this. That's going to be the same as, in terms of fractions, dm is 2/5, all right? And MA is 3/5, okay, of the total length of DA. Okay, so if we apply that, because the length of DA is 15, okay, so that gives us 2/5 of 15 is going to be 6, and the other one is going to be 9. So we have lengths of 6 and 9, all right? And that's going to come in useful. And we're going to label the height of this prism, EB, as H. Okay? Right, now, what do we want to do? It says calculate the size of the angle between EM and the base of the prism. So EM is effectively, how do we do this now? Like a slanted angle like that, right? That's the line. And in order to find the angle between EM and the base, we're going to have to use the flat line, the horizontal line, through the base, as it were, along the base, between M and B. Okay? So effectively, we have a triangle that slices through the prism itself at a funny angle. So that's E, M, and this is B. Okay? Now, EB, as we said, is H. All right? We now need to work out some other bit, like, for example, the base or something like that, because we want this angle X. All right? Okay, how are we going to go about this? First thing we're going to do, we're going to use the side face to work out the value of H, all right? And that again is going to be SOHCAHTOA, all right? So SOHCAHTOA, and that is, we have for this angle 35, the height HEB is actually the opposite, all right? And we know the base, right there, that's the adjacent, okay, the adjacent. So we want, in this case, something that links the opposite to the adjacent. So that's going to be tan, all right? So the statement is tan 35 equals H, so opposite, over the adjacent, which is 15, all right? And just to work that out, so we can use 15 times tan 35 equals h, which is, let me just punch that in. You've got 10.5. All right. That's h. All right. So h equals 10.5. Very important piece of information there. All right. So that's the first part. We can now use that, all right, to, well, later on to work out, let's say, the angle that we want, which is the angle EMB, if you like. All right. Okay. Next thing we need is to find, so we've done that, we need to find MB. All right. Now, if you think of MB as being, and I'm going to have to use another color here, MB is the diagonal for this triangle here. Remember, the base of the triangle, right, is a square. So the angle at that corner is a right angle, all right? And therefore, we can use Pythagoras. I'm sorry the diagram's messy, but there's no way around it, I'm afraid. Okay, so the second step, MB squared equals MA squared plus AB squared, all right? We already worked out right at the beginning that MA is 9 and AB we know is 15. Okay, so that is 81 plus 225. You don't need to write that. You can just put in your calculator and get 306. All right, so MB equals square root of 306, which turns out to be 17.49 at this stage. If you want to leave it in any other form, it's 3 times root 34. All right. Okay, so we have that next bit of information there. Okay, so for our triangle that we were talking about earlier on now, we know the height is 10.5 and its base, the adjacent to the angle that we want, is 17.49, and this is the angle that we're after. Okay, so again, for that angle, this is the opposite and this is the adjacent. All right, so use tan again. So tan x, the angle that we want, is given by the ratio 10.5 over 17.49, more or less 17.5 if you want, and therefore x equals the inverse tan, right? So on your calculators, press shift and then tan, and you get the inverse tan symbol, and it's the same ratio. You can put it all in one place. All right, so 17.49 or 17.5, and you will get an answer that is 30.96 dot dot dot, etc. And you can round that up. I think it doesn't actually, one decimal place. All right, so therefore x equals 31.0. Okay, watch out for that, because when you round the 30.9 with a 6 after it, the 9 changes to effectively a 10, a 0, and then you carry over the 1. All right, so 31.0, and because it's to one decimal place, you have to write the 0.0. Okay, watch out for that, otherwise you lose a mark. And the final question, all right, finally got there. Okay, what it's telling you is that you've got these sort of vectors around the thing. So CD is A, all right, got that? Excuse me, DE, right, the whole of that is B. So all of that, okay? F to C is A minus B, all right? And so what they want from here is express F to E, that one, in terms of A and or B, i.e. whatever is required, okay? So F to E, remember the route we're going to be taking is going from F to C to D to E, right? So F, E. I'm not going to bother doing the arrows above the things, right, just to save time, but you may want to use it in the exam. Okay, they're not going to mark you down for it. So FE is the same as FC plus CD plus DE, all right? So FC we know is A minus B, CD is A, and then DE is B, all right? So that comes to just 2A when you simplify that, all right? Okay. Okay, now we have the next part of the question. This is the tricky part. And it says X is the midpoint of DE. So if that's a midpoint, then that is a ratio of 1 to 1, okay? And each part must therefore be half B, right? Because the total is B. And then X is a point on FM such that Fx and Xm have a ratio n to 1, all right? The last bit, and this is the most crucial part of this question, that CXE is a straight line, okay? And let me just try and get that like that. That is meant to be a straight line, okay? And I'm going to actually talk about this for a moment, okay? If things are 3 points on a straight line, they are called collinear. I mean, all those points lie on the same straight line. That means going from C to X and then X to E, right? And indeed, let's put C, E, are all parallel. That is really important. Okay, they're all parallel. And what does that mean if they're parallel? It means the ratio of the components, i.e. A, B, etc., are same. Okay, so for example, if I have A plus 2B is parallel to 3A plus 6B is parallel to half A plus B, etc. All right, so bear that in mind. And the ratio of the components are the same for all three. You know what? I need to correct my English. I'll take 30 seconds here. Is same. All right. I was going to say ratios, but no. Ratio of components is same. Okay. Now let's get into the question itself, the actual meaningful part of it. What we need in order to actually start working on this, all right, is statements for example, FM. Right. First thing we need. FM, right, is basically going F to C, C to D, and then D to M, right, which is half of D to E, okay? So FC plus CD plus half D to E, all right? That bit is effectively DM, all right? So we go back to what we had in part A of the question, all right? So it's A minus B again, plus A, but this time it's half B, all right? So that comes out to be 2A minus half B, okay? Let's store that information for the moment. And the other thing that we need, which is, as I was saying earlier, using the relationship between C, X, and E is the most critical part of it, is that CE, all right, C to E is C to D plus D to E, right? So that's just A plus B, I think you can see that clearly. All right. Yeah, please do sort of like forward and reverse through the video to look at the picture again if you need to. All right. So we have these two results. We're going to need them shortly. All right. Okay. So CE is simply A plus B. What that tells us now, this whole rule about parallel lines is that the ratio of A to B, all right, on CE is 1 to 1. Okay. Ratio A to B is 1 to 1. Okay. So whichever one we take, CX or XC, and compare it to CE, each of those must also have the same ratio of A to B, i.e. 1 to 1, all right? So the coefficients must be equal for A and B, all right? So let's pick one. I don't know which one we're going to take. Let's take CX, all right? So CX is going to be same as CF plus, and I better draw this out actually. Let's take this root, all right? So CF and then Fx, all right, there. Okay, now I want to talk a little bit about Fx. You can see that C to F is going to be minus A minus B, all right? So just reversing that vector going from F to C. So you're taking the reverse direction, so it's a minus, okay? And Fx is the bit that we're going to now work on, okay? Just to say that if you have the full distance f to m, then remember the ratio is n to 1, so the total there must be n plus 1, and we know that f to x is n, all right? So using that, we're going to say that C to F and then F to X is going to be the same as C to F plus some proportion, right? So it's n over n plus 1 of Fm, all right? Okay, now tidying that whole thing up, all right? How are we going to write this? C to F, we've already said, is minus A minus B, okay? Yeah, and don't worry, I will get rid of all the brackets and things. Then we have n plus 1 times Fm. Remember, we worked out what Fm is, okay? There. So that's 2A minus half B, okay? And that effectively gives us this as Cx, okay? Remember the rule, the ratio has to be, of A and B, has to be 1 to 1 because these are all on the same straight line, okay? So that's what we're now going to say. Get all of this tidied up so we have all the A bits together and all the B bits together, all right? So let's see what we're doing. We have minus A plus B plus 2 n over n plus 1 A minus n over 2 n plus 1 B, okay? Right, so we're going to equate the coefficients. Remember the ratio, as I already said, is 1 to 1. So we can take the coefficients of the A's there and all of that, all right, and equate it to the coefficients of the B's because the ratio has to be 1 to 1, as I said. So let's go back to that. And what we have is coefficient of minus A is just minus 1. And then the second part is the 2n over, oops, hang on, there's an n missing there, n plus 1. And so that's going to be plus 2n over n plus 1 must equal all the b components. So the coefficient of b, 1, and then minus n over 2 times n minus 1. Okay. First thing I'm going to do is multiply everything by the 2 in the denominator here. Okay. So minus 2 plus 4n over n plus 1 equals 2 minus n over n plus 1. And bring all the n's to one side, to the left-hand side. All right. And that is going to come out to be 5n over n plus 1, and bring the minus 2 across to the right-hand side, and you got 4. Multiply that across, so we have 5n equals 4 times n plus 1, so that's 4n plus 4, and that leaves us with n equals 4. All right, so the final answer there is n equals 4. All right, that's been a bit of a long question to go through, but I hope that's helped. If you have any questions or suggestions, topics, etc., throughout this particular paper, please leave it in the comments, or indeed any of the other topics that you might be revising. If you have any questions about, your comments are always welcome. Do check out my other videos. The links will be on the screen somewhere. And there are other papers and topics that you might find interesting. And good luck with your revision, and thanks for watching.